let's get started. So I think it'd be good to start with some introductions. So I'm joined here with Brent, Forbes, and Dr. SK. And perhaps, SK, would you like to start with a brief introduction of yourself?
Sure. Hi, everyone. My name is Dr. Srujan Kotikela. I'm an assistant professor at Texas A&M Commerce and Raleigh campus. I specialize in cybersecurity and artificial intelligence. I'm primarily looking at synergistic applications between security and AI, how AI can make security smarter, and how security can protect AI.
Awesome. Thank you. Brett, would you like to follow?
Yes. Hi, guys. Joining you from sunny Australia, which is dark at the moment. So I'm a multidisciplinary guy. I do modeling in a lot of domains. I've joined SK and Tomás here because I've been fiddling with STIX for about 6 months now and really enjoyed the modeling challenge. And it's like a super exciting field. So yeah, I'm more into modeling, a generic modeler, and we got some exciting stuff. Tomás?
Yeah, thanks, Brett and SK. So for those who don't know me, I'm Tomás. I work as the Chief Operating Officer at Vatical. Vatical is the company behind TypeDB, and primarily I try to work with our users and be as involved as possible in our community, really to help people get started with TypeDB, as opposed to all other more boring work. But that's the more exciting part of my day job. So to start today, so what we're going to be talking about today specifically is a particular project that's fully open source. You can go online and clone it directly, which is this right here, which is TypeDB Data CTI. And before we dive into the details about what this is, we want to start with a quick demo of actually what you get once you clone it and once you start to explore the data with it. So to do that, I'm going to share a window of TypeDB Studio. And TypeDB Studio is a visualization software to visualize data in TypeDB. And I've just made a mistake here. So TypeDB Studio is basically a visualization tool to visualize data in TypeDB. And so at the moment, I've got TypeDB running on my computer, specifically effectively the code that you see in the repo. So we've migrated the data into TypeDB and we've run this query. And the query that you see at the top here is basically asking for fetch me an entity of type course of action which has an attribute of type name, and the name of that course of action is restrict file and directory permissions. Then we're also asking for another entity. That entity is of type intrusion set with the name blacktext. What we're then saying is give me then a course of action, that course of action which is connected to an intrusion set and that relation that connects those two must be of type mitigation, where the course of action, which is declared here with this variable name course, plays the role of mitigating, and the intrusion set plays the role of mitigated. Now, the result of that query is, well, fairly straightforward. It's basically an intrusion set. It's basically the query that we're asking. So we've got this intrusion set connected to this course of action, and we've got the two attributes that we were asking for. Why am I showing this? Now, the reason why this is interesting is because this relation right here, as the name of the type suggests, is inferred. So we're dealing here with an inferred relation, an inferred mitigation relation between the intrusion set and the course of action. Now, given that it's inferred, that means I can get an explanation for it. So when I double click on the relation, and by the way, I can also get this programmatically, I get an explanation for why that particular relation was inferred. And what we see is that the explanation shows us that apparently the intrusion set and the course of action are not directly connected with one another. Because the explanation for that inference that was made is because this attack pattern is actually mitigated by this course of action. And it's that attack pattern which seems to be using that intrusion set, or sorry, the intrusion set is using that attack pattern. But it gets more interesting because, and you can see this by the color of how we've color coded the relations, because this mitigation relation is persisted in the data set. And the data set specifically that we're looking at is the MITRE attack data set. And so this connection between this attack pattern and this course of action is not inferred. So this data is persistent. This connection is persistent. But this relation is not. So we're dealing with an inference in another inference. So we've got an intrusion set connected to an attack pattern that is also that is inferred. So again, now I can either do this programmatically or do this with TypeDB Studio. If I double click on that relation, I get the explanation for that particular inference. And that explanation shows us that the actual underlying data set, the actual explanation and the data that is actually persisted in the database shows us that this malware is actually being used by this intrusion set. And this malware is called WaterBear. And WaterBear is using this attack pattern, this indicator blocking, which is being mitigated by this course of action. So now, the purpose of showing these connections is because what we're seeing is effectively we're asking a higher level question with the query that we're writing here at the top. And that effectively is asking for data that doesn't actually exist. It's not data that is not persisted in the database. But but by creating the right logical structure in the database, the whole purpose and the idea of using TypeDB in this sense is that we can infer data that is actually also there by deductive reasoning. And that's the type of inference that TypeDB in this case supports. So again, the difference here is either between writing a query that tries to interpret all the possible connections that could exist between intrusion set and course of action, whether it's to a malware or whether any intermittent types, or just asking a higher level question, in this case, just a 3 to 4 line query that basically abstracts away the low level logic that we would want to have encoded in the database. So I hope that makes sense. And as we go through the presentation, hopefully it'll become more clear of how we actually get to build something like this. So now with that, I'm quite happy to hand it over to SK, who can share a bit more about the problem space where running such queries are useful. So SK, over to you.
Thank you, Tomás. That's a great presentation. Hi, everyone, once again. So I've been in cybersecurity for a while. I worked in industry. I done my PhD dissertation on cybersecurity, and I have interacted with various roles. It may be threat intelligence, SOC operators, and I personally was involved in developing malware sandbox and also developing cloud security solutions. And one of the things we notice is that cybersecurity data is inherently connected. Many times, analysts, either SOC or threat intel analysts, are given a single artifact or single alert and need to make a decision, whether it's good, bad, how serious, how realistic. And every time that decision needs to be made, the analyst needs to collect a lot of information to build a context around that and try to make a very informed decision. Now, many of the existing data modeling techniques make it very complicated to do this kind of analysis, because running several joint queries can take hours, if not days, depending on how nested you become. And parallelly, we are also facing another problem in cybersecurity domain, that is about lack of enough trained professionals. Now, when we don't have enough trained professionals, especially as an academic, I'm in the business of creating them. It is very hard to get really motivated students and keep them in the program until they finish it. Now, with this problem, and given the other complexities of cybersecurity, not to mention the increasing threats, especially accelerated in this pandemic situation, we have a huge situation where we need more effective and efficient solutions. Now, normally, when we talk about efficiency and effectiveness these days, all we hear is AI techniques. Now, ML is the predominant AI technique that is being used for a variety of solutions. It's great, except it's not very useful in many cybersecurity scenarios. There are two reasons for it. One, a lot of machine learning techniques do well with numerical data that can be put in vectors and matrices. And also, it doesn't take the context very well. So a knowledge graph-based artificial intelligence is a much better way to build things efficiently and effectively for the cybersecurity domain. And when I looked into TypeDB, it has built-in support to create that kind of structure. And one of the things that really attracted me is having the same conceptual and logical model that an analyst can think and work in with the same thing. So it's very intuitive in how you can reason. We saw that in the example Tomás has presented. You have a very high level reasoning, but TypeDB presents the constructs necessary to import our data and find these hidden threads and hidden solutions that are not very explicitly coded or not apparent. So this reduces the cognitive workload on analysts so that they can dedicate more time in actually solving the problems, not a lot of data wrangling and going across. And also being a graph database at the foundation, TypeDB actually provides a context associated with any node, any artifact in the database almost naturally. So I think there is a lot of benefit in doing things this way. And I'm hoping to see what else we can do with this. Thank you, Tomás.
Awesome. Thank you, SK. I think there's a lot to unpack there, but it's been very interesting. And so, for those who joined a bit later, so SK and Brett, who speak in a second, are helping to lead the project from a community perspective, and it's been really interesting for us as a technology builder to see the applicability of our technology within the space, and that's why some of the insights that we've been able to gather in terms of how TypeDB, how this project could be used, are very relevant. But before getting into that a bit more in depth, which Brett will speak more about after me, is to say a few words about what we've actually built. So I said initially that the project is a very new project. It's a community project. We invite anyone to critique it, to join, to contribute as much as they want, whether it be in CTI or other areas of security. But ultimately, this open source and the repo on GitHub is really a knowledge graph to manage CTI knowledge and discover new insights about cyber threats. And right now, it's still very much a POC. We've incorporated the MITRE attack data set. So there's a connector to load MITRE attack data into TypeDB. The data model itself is based on STIX 2 to enable the ingestion of heterogeneous CTI data according to what, as far as I understand, is the most widely adopted data model in the CTI space. And then we've built it, of course, on TypeDB. And in the coming slides, I want to share a little bit about the rationale behind using TypeDB and why, when I was introduced to STIX a couple of years ago, I felt there was such a natural fit with the data model that we invented or that we implemented in TypeDB. So, but first, a couple of things why we see TypeDB being so useful. There's a lot more, by the way, to unpack here, and SK mentioned that already a little bit, and Brett will continue in a second on this. But in some ways, we can structure those into looking at the expressivity of the language and the ability to do logical inference. And when we talk about the expressivity here, we mean the expressive data model that TypeDB gives to represent complex data and enable the contextualization of that same data. And we'll get into that, specifically how and why the data constructs that TypeDB supports in a second. And the second part is that of the logical inference. So once we've represented our data in TypeDB, we can use the reasoner, the inference engine, to discover previously unknown insights from existing data, whether that's to detect and respond to new threats or much more. So this is really just scraping the surface. Now, for those unfamiliar with STIX, STIX stands for the Structured Threat Information Expression, and it's a language to describe CTI data It's incredibly thorough. Oh, it's incredibly thorough, and Jane and everyone else from the OASIS technical committee has done an absolutely incredible job to write the whole specification, and the amount of effort and passion that's gone into the language is absolutely hands down to the team, and it's been really a privilege to be able to interact with some of them, and without getting too much detail into the specification, what we describe in STIX, there's roughly 18, I believe, 18 domain objects. There's a lot more other objects from meta objects, from cyber observables, but it's based on a graph format. And so that graph format basically, and this is an example of such a graph representation, where we have a domain object called an intrusion set, which is represented in a JSON format here, which has a bunch of properties that is connected to a malware entity, which is the second object that you see here. And then the third object is a relationship. And the relationship is of type uses. And that is effectively the edge that connects the intrusion set to the malware. But where it gets quite interesting with STIX is that relations are considered to be first-class citizens in the model itself. And one of the consequences of that is that we can actually create embedded relations. So here we've got a created by ref, which connects the uses relationship to some identity object. And we'll see in a second why that's interesting for TypeDB. And there's more to it, but I just wanted to highlight the graph nature of the model that the STIX dataset is moving towards, because indeed CTI data and security data in general is inherently connected, is inherently complex, and requires a model that considers at least relations to be first-class citizens in the model. So how do we go about modeling the STIX specification? Now, STIX is big, and there's a lot to it, and it's a big document. Again, it's an incredible work that's been achieved. But the way we went about it is to consider the different objects that exist, and the main sort of core of that are the STIX domain objects. And then there's 18 or so of them, each sort of identified in their own chapters. And the way we then modeled this, and this is an intrusion set right here, is simply considering we've got a SDO, which stands for a STIX domain object, which we modeled as an entity here. So this is if you're unfamiliar with TypeQL, this is the schema language. Here we're defining an entity. We're saying the STIX domain object is a type of entity, specifically a subtype of a STIX core object, and it owns a bunch of attributes, and it plays a relation, in this case, an indicated relation in an indication relation, the role of indicated in an indication relation. But then because there's a lot of subtypes of these SDOs, we extend the SDO object by creating a sub-entity, in this case, an intrusion set, which is a subtype of a STIX domain object, which has their own attributes and relations. And we do that for all of the different objects and the entire model until we get the right model. And again, this is still very much early days, so there may be things that we haven't done right. And between ourselves, we're also having discussions about how best to model it. But the very fascinating thing about STIX is that it's a very hierarchical model in the way it's defined. And this is one example where we've got an SDO object that is inherited by the intrusion set, which extends it by adding more attributes and more connections to other relations. And then if we consider holistically what the whole model looks like from a modeling perspective, the most high-level object that we've modeled currently in the STIX schema, and this schema is a STIX object. And from there, we say there's a STIX core object and there's a STIX meta object, which then are divided into a STIX domain object, a STIX cyber observable object, and then for the meta object, we've got the marking definitions, the external references, and the kill chain phases. And then further, under the SDOs, we define all the different SDOs. We do the same for the cyber observable objects. For the marking definitions, we divide them under statement markings and TLP markings. And TLP markings, we divide under 4 different whites: the TLP white, the greens, the reds, and the ambers. Now, how does that look in code? Now, one of the benefits that we hope you'll see when working with TypeDB is that now this is a very complex model already, and making sure that the database maintains integrity in terms of what data goes in means having some language that can describe this in a hopefully expressive enough way, in a way that doesn't make it too complex, but expressive enough to also describe that complexity. And the way we do that in TypeDB, as you saw in the previous slide, is just simply by using the keyword sub and literally subtyping every object, every entity that we've defined. In this case, the model itself becomes quite straightforward to model. And of course, here we haven't bothered to look at any attributes because we just wanted to focus how simple and how hopefully easy you'll see it is to model what is a fairly complex domain in a hopefully a very readable and maintainable way. So if we then look at more complex relations and how we would go about modeling this, I spoke previously already about embedded relations. Now, embedded relations are effectively nested relations in TypeDB. So consider this example. Here we've got a threat actor entity, this object here at the top. It's of type threat actor, and we've got a relation. The relation is the type is relationship. That's the type according to the STIX definition, and its relationship type is indicates. So in TypeDB, what we do is we define this as an indication relation. We see that there's three embedded relations. There's the created by ref, the object, and the two object markings for these two things. Now, to showcase how we would go about creating an embedded relation in another relation, because this is where it gets really interesting compared to some of our other database friends, is that modeling relations in other relations becomes impossible if you're using a normal traditional graph database, because you can't have an edge referred to another edge. So what you do instead, you end up reifying your graph where this indication relation, instead of being an edge, becomes a node, or in other words, an entity. And whilst technically that solves your problem, because now I can create a relation, an edge between an object marking and the relation, that itself means reifying our model, which means effectively, well, messing up our model, and that's what we don't want. We want to maintain integrity of the data model itself. And so that's why what we instead want to be doing is that for this indication relation, we say that the indication relation itself can be in another relation. So this marking definition right here refers to this TLP red entity. And we say that this TLP red plays the role of marking in an object marking relation where the indication relation plays the role of marked. And then here we've got the threat actor, and the indicator is not shown here just for simplicity, but they do refer to the source ref and the target ref, the indicator and the threat actor that connects these two in this binary relation. Now, how does this look in a TypeQL path, in a TypeQL query? This would look like this. So if we were to describe effectively the TypeQL query, we see that what we do effectively is we say that the indicator, this one here, this variable, we assign it to this entity. We then say it's got an attribute. We say there's a threat actor, the joker, and we say there's a TLP rep, which is this entity right here. And then in order to create the right relations, we first create the relation between the indicator here and the threat actor in this indication relation. But what's cool here is that we're able to actually assign this relation to this variable here, this IND. And then this relation itself then plays the role of marked in an object marking relation. And that's how we can effectively get relations to play other roles in relation, because, and I said this before, but STIX considers relations to be very much first-class citizens in the model. And that's the same way how TypeDB views and sees relations as well. And another example of some of the data constructs that TypeDB supports are hyperrelations. So one of the things that we modeled is a network traffic source. We modeled a network traffic source relation that has an object, an entity here called network traffic that plays the role of the traffic, of course. There's a payload, the artifact, and there's a source. It's coming from an IPv4. Now, we can't really have hyperrelations in a binary graph. because the whole idea of a hyperrelation is that instead of thinking of a relation as a pair of things, a hyperrelation in this case, we consider that to be a set of things. So n number of things, in this case 3, that play a role in one, play different roles in one relation. And we can in a very simple way represent that in a TypeQL query by simply saying, attaching these 3 variables here, the IPv4, the artifact, and the network traffic, in this one relation where the IPv4 plays the role of source, the artifact plays the role of payload, and the network traffic plays the role of traffic. And I hope you can see how this is not limited to a number, to let's say two things that play a role in this one relation. We can have a number of things in that relation. And another useful data construct in TypeDB is that how we modeled it for STIX. And you saw that already, our type hierarchies. Now, another place in the STIX model where we use type hierarchies were in network traffic. So we've got 4 different network traffic entities that we created. And again, we can very simply create those network traffics by just using the keyword sub that creates the right levels of hierarchies. And by using effectively the type hierarchies, what that means is that let's say we want to be returned all the network traffic entities that have a protocol IP. Now, if we're using any other database, we would actually have to write every single instance of network traffic. But one of the reasons why you would want to use type hierarchies, because we get type inference, because by querying for the parent, in this case, the network traffic, we actually infer every single subtype that we're asking for, and effectively the query becomes much less verbose. And of course, this can become much more complex and if we have a more complex hierarchy. So then how did we create that inference, the demo that I showed? How do we actually build that inference? Now, the way we did that is as follows. So if you remember, the query that we saw basically is asking for a course of action that's connected to an intrusion set through a relation type mitigation, where the course of action plays the role of mitigating, and the intrusion set plays the role of mitigated. And then this is the result. So now, if we saw, when we double click on this relationship, we basically got this back. We got the explanation that the intrusion set is actually connected to an attack pattern, and that attack pattern is connected to a course of action. Now, how do we get that inference? Now, the thing with TypeDB, and as part of the schema, we effectively create rules. And what a rule does is enables us to abstract away certain logical patterns to infer some higher level abstraction. And in this case, we're looking at a very simple rule where we've got the body of the rule, the when part, where we basically say that if a course of action is connected to an SDO, so a STIX domain object, and if that SDO is connected to an intrusion set, then connect the course of action with the intrusion set. It's a very simple relation, but the interesting thing here is that because the SDO can be 18 different things, we're also using the type inference to effectively abstract away a lot of complexity. That if you were to write this query out in terms of the actual into the actual query paths, you get a combinatorial explosion in terms of query paths that you would have to write. So this very simple query already saves us a lot of hassle in actually trying to abstract away a lot of the lower level complexity in the actual data. But it gets more interesting when we actually in the conditions of the rule. So we also have inferences because this relation right here, this use relation between the SDO and the intrusion set is also inferred. If we remember this relation right here. So when we double click on it, if you remember, we get this explanation. We see that this intrusion set is actually connected to the malware, and the malware is connected to the attack pattern. And that's an example of a transitive relation, a transitive usage relation, which again we represent in a rule in TypeDB like so, where we say that if one SDO is using another SDO, and if that SDO is using another SDO, then the first SDO is using that other SDO. It's a very simple rule, but we're able to create very, very standard and very easy in a very easy way, maintainable and expressive way, we're able to create transitive inferences this way. So I hope that makes sense. There's a lot more to cover, and this really just touches the surface. But hopefully this at least introduced you to how the expressivity of the data model in TypeDB helps to sort of represent this complexity of data and to really create that contextualization of CTI data, while also using the inference engine to infer insights from data that's already in there, whether that's to detect and respond to new threats. So that's the end of this part, and this is my cue to hand it over to Brett and SK. We're going to talk a little bit about the project in practical terms, as well as the future.
Thanks for that, Thomas. That's brilliant. I hope everyone saw some of the capability there. Hopefully you can see my screen. I just want to talk a little bit about the repo. So there's been quite a bit of work on this discussion about various models. But what we have in the repo is a prototype model, which is quite expressive, as you've seen. It loads the MITRE attack data, and it allows you to pull through a few queries, just a little bit of housekeeping to get that going. You just obviously need to pull the repo, use a virtual environment. TypeDB needs to be loaded to be downloaded separately. You can just download that from the website. It's open source. You can run it on your local laptop, or indeed set it up as a server, and you put the details of the where the TypeDB is loaded in as a Python argument, and then you can run. You can download this, set up a virtual env, and run it, and you'll be able to have a play with it yourself. As I said, we've loaded the Thomas has loaded the MITRE attack details, and SK and I are going to be running the community. We've got like quite a strong agenda. So just briefly, one of the plans that we're going to, that I'm halfway through doing, is we're actually going to integrate with one of the Oasis projects. So that's the CTI Python STIX 2. We're going to be a default data store. So if you go to the STIX 2 library, we'll be one of the default data stores in that, both a source and a sink. I'm actually got that underway as we chat. And that will mean that everybody who uses the STIX 2 library, we hope in the next couple of months, we'll be able to issue an update that allows people to have TypeDB as a data store, and then just add and query records using the STIX 2 library. That's in addition to what Thomas has already prepped up. And what that also does is make it very easy to add taxi. So we want to also get the taxi sources added, because there is on the Oasis Open, there's a taxi client and a taxi server. And the aim is within a couple of months to have both a default data store and sync, to have a taxi client and server. And then when I think it is Rich and some of the other amazing crew out at Oasis release the interop tests for 2.1, which hopefully will be done by the end of first quarter, we'll be ready to get certification as a source and a sync. And at that point, we'll really have something which is generically useful. So that's quite exciting. But SK and I are going to be running a community. We want people to come to Discord. There's a Vatical Discord you can get to. It's a free link if you go to the website. And we'll be meeting monthly, and everybody is welcome to come and put their changes on. As I said, after we've done STIX and taxi certification, there's quite a few steps that we want to do. I'm going to turn it over to SK in a second. He's going to talk about where we're going to take it after this initial phase, but it's really quite an exciting project to be the default database and reasoning system. There is one additional amazingly powerful capability that Thomas didn't have time to express. So A guarantee of the database is that attribute types and their values are loaded only once for each unique value. So if I have an IP address 4, it's guaranteed that any IP address is only held once uniquely, and every data object that uses that just links to it. What that means is you can import data, and anything using that IP address, that hash is instantly available through a query. So joining the dots between, once you've got your data described in STIX, then joining the dots between that and many other records becomes very easy. I'm going to hand over to SK. He's going to talk about what we're going to do once we've got the certification, the more medium term and longer term plans. And as I said, he and I'll be running the committee. We'd love for you to come and join us and work with us towards making a brilliant open source product. Thanks, SK.
Thanks, Brett.
Hang on, let me get rid of sharing. It's somewhere here. Okay, there's a little bit of a challenge on the, oh, there we go, screen sharing, stop share, brilliant. Okay.
Perfect. Thank you, Brett, for the excellent demo. So short term, we are very much focused on doing it for STIX and Taxi, but in the long term, we want it to be a very public repository for all threat analysts and security analysts, so that everybody can come and do the analysis and research for any threat they have on the system. We will probably be upgrading a more better visualization layer that's easier to use without you directly using the queries of TypeDB, so that any analyst with any background will be able to do the research. And we want to make it a social platform where people can collaborate and contribute to all the threats. And we want it to become a default open source threat intelligence repository that anybody can use without even installing on their premises or in their infrastructure. And super long term, if everything goes well, we want to expand our data model to other data sets as well. And then we want to create an integrated security analysis platform. But that would be super long term, depending on how well the community receives it, and we'll take the feedback and try to improve upon it. And then we want to incorporate as much security open source data as possible and make it available for anybody to link all the dots naturally. Like Brett highlighted, TypeDB is uniquely capable of storing one instance of one data, which means if you want a context, you just need to pick it up, and all the relations and contexts are immediately available to you, because that's exactly how it is stored in the backend. Now we would like to open up for a Q&A. Thomas, do you want to say anything?
So I know Patrick has been dying to, had his hand raised for a while. So Pat, I'll allow you to talk. Are you able to?
Can you hear me?
Yes, we can hear.
Yes.
No, actually, I thought you guys were doing a wrap up, and I wanted to make sure I wasn't listening in on a wrap up, so I didn't realize the webinar was still going on. So I just want to let you know I was out here listening. I didn't realize you were still live. So I have 1,000 questions, but I had a senior VP presentation that I found out I had to give this morning at exactly the beginning of this, so I missed it all. But I do have 1,000 questions.
We'll be publishing this on YouTube, so you'll get the link. I'll personally send it to you as well.
Okay, edit this part off. Or I'll grab a guitar and start singing, maybe.
Okay, good. Okay, cool. Is there anyone else who has any questions?
While we're waiting for questions, I will say that Patrick's joined us on the community, and we're looking forward to working with you, Patrick. So one of the things that's super interesting to us is, you know, as an extension, as SK has mentioned, is temporal analysis. So temporal analysis is a whole thing that I love. I know it's a bit geeky, but, you know, we really get into it. So there's so many exciting little projects that we can spin off if you come and work with SK and myself. So please do join our Discord. I'll put the link in the chat, but you're welcome. SK's obviously called Dr. SK on Discord, so that's pretty obvious. My name's Modeler, and you can hit us up at any time.
Great. And I saw Imana has their hand raised. Are you?
Yeah. Hello. That last part about temporal analysis is very exciting to me because I do graph temporal analysis. So looking forward to that. But I do have a couple of questions. One of them is when does the inference happen? So is it when you run the rule, or is it when you actually do the query? And my second question is about this embedded relationship part. How does it affect the query? As in, let me look at the example that you gave. So suppose that, what is it? Trying to find it. Yeah, suppose that your threat actor and you're trying to figure out if there is a TLP read connected to it. Is it directly queryable without knowing that there is that embedded relationship, or do you have to know that object marking is embedded into indication? Does that make sense?
Yeah, so let me address the first question real quick first. So the inference itself happens at query runtime. So in short, when you run a query, TypeDB just checks what of the concepts that have been written in the query itself. Do they participate in any conclusions in any rules defined in the schema? If yes, then it's going to check the conditions of that rule, and it's going to check the data only at query runtime if any of those conclusions work as well. At the same time, it's going to also look at do any of those concepts participate in any conclusions of any other rules. So it goes on. I hope you can appreciate that if you could have 100 rules that are queried at the same time that way by having chaining of rules that way. But the question is at query runtime. So only those rules that are relevant to your query are going to get executed. Now, in terms of perhaps I can pull up the slide on the nested relation. So nested relations effectively mean where is it? Here. A nested relation, the only thing that it means really is that we can now have that we can declare this relation here to be in a variable, and then it can participate in another relation. At the same time, if I was querying, I could also just query for, let's say I don't know that there's a relation in there. I could, let's say, just query for any object marking, like so, marking, let's say call this X, and then say marked, what's marked, I don't know, anything can be marked. So I'm just going to call this X. So X can be anything now. And marked is the TLP, is an object marking. So this way, now X can be anything. X can be an attribute, X can be a relation, X can be an entity. Does that help?
Yes, it does. But my question, I guess in this case, it would pull indication out instead of threat actor or indicator. So my question, I guess, would it be possible to do marked and then X would be indicated?
Sure, yes. We just change the variable, right? So we just say threat actor. If we're talking about, if we've declared, let's say this is a query, this is just independent of one another. If we've declared that threat actor is a threat actor, then now we've filtered all these, only instances of threat actors will be looked at in this relation. I could also just say is an entity. Now it's going to look at any entities. I can also just say relation. Now it's going to look at any relations. If I leave this blank,
so it does indeed bypass the indication relation.
I mean, again, it really depends what you define here. So if I call this an indication relation, then it's only going to look at indication relation. So
okay, perfect.
The answer is whatever you want it to be.
Okay. That's
I'll just say there, that I've also posted on the chat channel a link to an article we did on time, or I did on time. So that's well worth having a look at, Emain. So pretty much when I first came to TypeDB, people are like, oh, graph databases can't do time. Well, it turns out that TypeDB uniquely has a super powerful capability over time, and that can be pushed to the level of a specific time database. And it's worthwhile having a look at how that works. That's a whole subject on its own, but I just dropped the link there for your interest to check it out. And that's something we would like to bring in, as well as in the rules. You've only seen rules kind of applied one by one here. You can build actually like a data projection mechanism. I've built rule sets that allow me to do full process mining. In other words, I import a data log, and then I can query out a BPN control flow that describes that data log. And I do that through having a series of interlinked rule sets. So you can create quite a bit of power through the rule sets. And just wanted to talk to Patrick's question. He goes, is there any existing tooling for converting our RDF and into TypeDB? Well, I will say I'm actually also leading an initiative. So in RDF-OWL, there is a group called Semantic Arts that produce a set of upper ontologies called Semantic Arts GISTs. And we're working with them to port the Semantic Arts GISTs over to TypeDB, so that we'll have bidirectional capability, so that we can load data from RDF-OWL and export it out to RDF-OWL. But in general, what we don't want to do is try and represent RDF-OWL schemas here. It all gets a bit complicated, but most of them are pretty ugly and verbose. TypeDB is a lot more elegant, as you've seen. Pretty much you're going to want to rewrite it so that it works more effectively, rather than copy it through some kind of transform mechanism. So I will point out TypeDB is a lot more effective. You can build in things like STIX and lists and all sorts of sub data structures in that you just cannot do in RDF-OWL. So you don't want to just import a RDF-OWL directly.
Great.
Yep. Over to you, Thomas.
And I saw Dana had a question. If you'd like, I could give you, allow you to talk if you'd like to pose your question live.
Thanks. We've been looking at the NIST attack data as a source, and again, the problem for us has always been that the data are not necessarily numerically oriented, so not as useful for ML, and also teasing out the relationship structures. So I just had a question whether anyone had given thought to using that as a potential data source. We've done a census of records from the 1999 to 2021, and we can give that over to people, but I just wondered if anyone had given thought to whether that's a good source or not. Over.
Thank you.
Yeah, if I can answer that. Well, I might say something, I'll push it on to Thomas. So when I chat to, I'm the modeler, and when I chat to SK goes, oh, yes, we want to pull every piece of data. So yes, NIST has come up, threatminer.org, Twitter, I mean, all these different formats for pulling data are seen as desirable because we want to create TypeDB as the unification platform for the description, and for a lot of reasons, because it's advantageous. So NIST is on the list to add. As I said, my first role is to get the STIX taxi thing fully certified and up and running. But then SK has given me a big list of other things he wants me to bring in and integrate. So yes, we would be pulling in the NIST stuff and integrating all of that. Thomas?
We may just give it a go. Over.
Sure, we would definitely appreciate it, Dana.
Yeah. Come and join us on Discord.
Yeah.
We will do. Thank
Come
you.
to a committee meeting. You can raise that as a. So what we really want people to come to is come to us and say, okay, I want the NIST database, right? Because that helps set the priorities of the committee and any of the workers that are going to contribute their time. So we know if NIST is important, bang, we do that straight away. So yeah, come to the committee, hit up SK or myself on Discord, and we'd love to add in your requirements and get all that added. So basically almost any data source that you want, we want to know a big list of them, because SK just keeps giving me a list. Oh yeah, pull that in and pull that in. And so yeah, that's the exciting future.
Yeah. SK, is there anything you want to add to that? Or?
Oh, no, I was just welcoming Dana. Yeah, we would definitely appreciate any new data source or any requests you guys have. Like Brett mentioned, we want to make this the de facto public repository for all kinds of threat intel. We are looking, thank you.
So we've got an anonymous attendee. So I can't actually ask them to speak, I think, because they're anonymous. Yeah. So I have no idea who asked this. So perhaps the two of you may know the answer to this question. So can you explain some integrations about how fast can you go from an attack to real-time prevention? Basically an explanation about time to prevent specific ATPs. I think that's a question for you, SK. If you need any clarification, we can ask.
Sure. Can you repeat the question?
So the question is, can you explain some integrations about how fast can you go from an attack to real-time prevention? Basically, an explanation about time to prevent specific ATPs.
ATPs, maybe they meant APT, I'm not sure. But time to, from an attack to time to prevention, in general, or with using our TypeDB CTI. This is primarily a research and analysis platform. We, as of now, are not envisioning how to integrate into real-time systems. Once we have established the foundations and our short to medium-term plans, as discussed previously, we will consider how to integrate into the real-time systems. But as you must be aware, most threat intel data is provided as a list of IP addresses, domain names, or hashes, etc., that can be integrated into existing controls. So once you have the threat intel, you can integrate into any of the real-time enforcing systems. But whereas our platform specifically is for research and analysis, where we want to provide all the context and connect all the dots so that you can reason and analyze as quickly as possible. I hope that answers the question.
If I can add to that, SK, so one of the things that, there's some great CM products out there that actually do real-time analysis of threats. That's not necessarily where we're going. In general, what you have is a tool set that analyzes a threat. Then you're going to report that out in STIX. Hey, I found this threat. And then the question is, where else has that occurred? And where else, what's the context around that? So we really come after you've probably recognized a threat and reported it in STIX. So there's definitely roles, there's different kind of roles that go through the life cycle here. And as SK is showing you, we're not in the real-time analysis role, where after the threat's been found and that's been actually reported, people who build the context around it, the so-called threat analyst, that's really where we see ourselves fitting. So we're not trying to compete with existing security tools, but add to the security tool stack and integrate them all. That's really where we're going to, the one ring to rule them all. So rather than trying to replace them, we're going to push data from them. Yeah. Over to you, SK. And
yeah, and I see Samuel has a question as well. Samuel, if you'd like, I'm happy to put you on speaker.
Yeah, I can unmute, but I have my children, so I will speak up about my question. So my question was about the Take C2 server you mentioned, I think at the middle of the meeting. Is this Take C2 server will be let's say, integrated to TypeDB, of like native stuff you're doing with TypeDB, or this is part of this, let's say, side community project and will be implemented elsewhere as like a standalone Python process?
Yes, I can add to that. So Thomas and I've been working a little bit on the STIX. He's done a lot of it, and we've produced essentially a prototype. And what we're going to do is push the code base forward. And as I said, my first job that I'm doing at the moment is integrating with the STIX2 library. The reason I'm doing that is it makes it easy that we can be a default data store for anyone using Python STIX2, but then it makes it easy for me to also add taxi. So as you know, on the Oasis GitHub, there's a taxi client and a taxi server, and I'll be leading the effort to integrate those two plays. The actual taxi server at the moment is a Python Flask server that sits on MongoDB. We probably won't change that too much, but it will be fully integrated, so you can use any of the facilities of that library to pull data to and from TypeDB without having to issue TypeDB queries. It'll all be fully integrated. So our aim in the short term, by that I mean next month and a half type of scenario, is to fully integrate with the STIX2 library and the taxi client and server, and to have that based on the GitHub. So anyone who pulls those repos, they can just use TypeDB as a source. That would be the aim, and that makes it useful to the community as quickly as possible. And obviously after that, we also want to seek interop. And I know Jane and Rich and some of those other big brained folks over at Oasis are working hard on the interop test. And we hope that's going to be ready by the beginning of Q2, so that we can be properly certified as a valid STIX2 and as sync and source, and also a taxi client and server. And that would just be part of the open source repo. You pull it, and that's the capability you get out of the box, right?
Yeah.
Because that makes it useful for the community. That's where we're coming from. Please come along to the Discord, join our community. If you want additional features, you can put your hand up and we add them into the list. Yeah, so please come and be involved.
Is that useful, Samuel?
Thank you very much.
Awesome. So I know we're over time. So if anyone has to jump off, I fully appreciate it. But I do want to make sure that we answer Ron's question. If you'd like, Ron, I'm happy to allow you to talk. Otherwise, we can, of course, just answer your question live as well.
Hello, it's Ron. This time from Israel.
Hi, Ron.
My question is, so far you described a deterministic relationship, meaning a certain relationship. However, in most of the relationship, there is also uncertainty, such as probability. Do you support that as part of your data model, as part of your taxonomy ontology, or if so, how do you do so? Thank you.
Go ahead, Brett.
Okay, so there's a couple of ways that we can go about that. So at the moment, Ron, what we're doing is a faithful representation of the STIX2 library, and so that means we're associated specifically with the standard. Some of the people who are on this call that I've spoken to previously are going to help us build machine learning, probably initially with a convolutional neural network and pushing out into graph neural networks. So once we've got patterns in there, we can go and look at other patterns and recognize those and write those back into the database. In terms of actually including probability things in records, there is actually a probability field in some of the STIX2 records where you can kind of give a certainty, and yet there's that there. In terms of us calculating probabilities, that's a little bit further out. I've actually got that on the list of Vatical to-do things that we're going to bring in calculation, hopefully towards the end of the year, so that the rules would involve calculations. I can run calculations as part of the rules. So there is quite a great future for doing those types of things, again, on TypeDB, which is pretty unusual in a DDL that you'd have that kind of capability. Sorry to get excited, but I get excited by that kind of stuff. And, so
Mhm.
there's quite a few things that we can do, from pattern matching and even pushing out in the future towards doing calculations in rules. Thomas?
Yeah, no, I think that's great. And yes, I mean, the general feature there is to be able to do arithmetic in rules. So the rules that we showed in the presentation are really basic rules. But imagine doing n+1 as a conclusion, or other arithmetic rules.
Well, also, if I put log2 in those rules, I can build my own decision tree. Boom, as a set of rules, right? I can start really doing stuff, calculate entropy, and I don't get me excited because it is exciting. But, we're real keen for the calculations to come through. That's going to come through a bit later, and that's again another extension that we can bring on, and that'll just be built in. So if you do it, boom, you just got your own decision tree built in. So there's a lot of capability we can expose through TypeDB.
Yeah. Michael Sullivan also says calculating IP ranges.
Yeah.
Does that help, Ron? Do you have any follow-on questions?
Yeah, it answered the question. Thank you very, very much.
Awesome. So if there's no more questions, if you do have, please feel free to put them in the chat. We'll make sure to answer all of them. But do join us on Discord. So we've got a special dedicated channel called TypeDB Data CTI, where you can post any questions that you have. If you like the project, do give us a star on GitHub. That would certainly help to spread the word. And like Brett said, watch out for the announcement. We'll do a committee meeting soon. It's a lot of work there. Dana, thank you for I think that's great that you'd like to contribute. Yeah, also looking forward to working with everyone. So I think we can leave it at that. SK, Brett, any final words?
Come and join the community and work with us because it's so exciting.
Yes, it's great to see you all, and I hope you all enjoyed this. Please join us on Discord, and let's build this thing. Thank you.
Awesome, great. Thank you so much, everyone. Thank you, SK. Thank you, Brett, for staying up so late or waking up so late. And I'll see you guys around.
Okay.
Take care, everyone. Bye-bye.
Bye-bye.